An arrow is shot at an angle of 50 degrees with respect to the horizontal. So the 50 is here, 50 degrees. It reaches the bow at a height of 1.5 meters, meaning that this y, or we are saying here, is 1.5 meters above the ground level. Its initial speed is 15 meters per second. All right, 15 meters per second, that's the initial speed. Now the first question we have is, what is the maximum height of the arrow measured from the level ground? So this is the capital H, that's the one we want. Now the first thing is we need to find this small h we are able to see before we can find the capital H. Now, when the arrow is short, when it reaches this point where it starts turning, the final velocity at this point is going to be equal to 0. Why? This final velocity is in the y direction, because velocity in the x direction is always the same. So the final velocity in the y direction is going to be 0 at that point. So that's the analysis that we're going to use. So we're going to say 2gh is equal to v squared minus u squared. So be 2, g is going to be negative 9.8. Because we are going up, the h is going to be the small h. Final velocity is going to be 0. All right. The initial velocity now, because we are talking about height, this should be in the y direction. Initial velocity in the y direction is given by velocity sin theta, and the velocity here is 15. Sin the angle of the floor, we've been told, as 50 degrees. Now we are squaring this one. All right. So from here, to able to remain with h, we are going to divide both sides by 2 multiplied by negative 9.8. Even this side by 2 multiplied by negative 9.8. Therefore, the h that we are going to find, the small h, so it's going to give us 6.74 meters. Now, remember the question was saying the height with respect from the level ground, that's capital H. So capital H is going to be equal to small h plus the initial height. Small h, that is 6.74. The initial height from the floor, that is 1.5, and that is going to give us, all right, what value are we going to get here? That is going to be 8.24. Okay, that is it. So that is it for the first question in here. Let's look at the second one. How long does it take the arrow to return to the level ground? So it moves from this maximum point, it goes and reaches the level ground there. How long is it going to reach? Take the arrow to reach there. So we're going to use two methods. The first one, we're going to say height is equal to ut plus half gt squared. So the height, we can see that's 1.5. Now, because we are going to the level ground, meaning that the final height is going to be 0, and then the initial height is 1.5. So height is final minus initial. Final is 0, the initial is 1.5. So 0 minus 1.5 is negative 1.5. So this is going to be negative 1.5. That will be equal to initial speed. Okay, now because we're talking of height, it should be initial speed in the y direction. How do you find initial speed in the y direction? 15 sin the angle, which is 50, then multiply by the time of flight, then plus half. G is going to be negative 9.8. Why? Because the ball is first going up, and then t squared, or whatsoever is short, is first going up. So this is going to be, if you multiply half by 9.8, that will be 4.9. It will be negative, but I'll get it and take it the other side of the equation. It becomes positive 4.9 t squared. And then if it's 15 sin 50, we are going to get 11.49. If we also take it the other side, it becomes negative 11.49 t. And then we have got also the negative 1.5 the other side, and that will be equal to 0. So using the quadratic equation, it is going to be negative b, negative 11.49 plus or minus square root of b squared. B is still negative 11.49 squared minus 4. A is 4.9. C is negative 1.5. Everything divided by 2A. And A is 4.9. So if we get to punch this, we're going to find our time to be 2.469 seconds. Now we're going to get also a negative value, but you don't consider the negative value, alright? So you only get the positive value because you've got a positive or negative. So only go for the positive value. Okay. This is method 1. We found time to be 2.469. Let's go for method 2. Now for method 2, we're first going to find the time from this point to the maximum point. We're going to call that T1. And then from the maximum point to the bottom, we're going to call that T2. So T1, we are going to be able to say that V is equal to U plus GT. Now we know that the final velocity at that maximum point, the final velocity here in the y direction is going to be 0. Alright? The initial velocity in the y direction, whenever you're using g, should be in the y direction on projectile motion. So initial velocity is 15 sin 50. Since we are going up, g is going to be negative 9.8. I'll take the 9.8 the other side, and that will be equal to 15 sin 50. Divide both sides by 9.8. So this will give us T1 being equal to about 1.1725. And then we're supposed to find T2. Now to be able to find T2, since we don't know the final velocity at the bottom, we cannot use this equation because we don't know it. The final velocity at the bottom will not be 0. So we can say height is equal to ut plus half gt squared. Now the height is going to be the total height from the very top to the very bottom, and we already found that. If you remember in the previous question, we had in question 1 we found 8.24, and that should be equal to, now the initial speed, since the initial now is this position, is going to be 0. All right, so that is going to be 0 as the initial, and then plus half. G is going to be positive 9.8 because something is dropping. Okay, so this will be 8.24 is equal to half into 9 times 9.8, that will be 4.9 t squared. Divide both sides by 4.9. Alright, so we're going to have t squared being equal to 8.25, I mean per 0.24, 8.24 divided by 4.9. So we're going to square root both sides for us to remain with 2 and with t, and this t we are remaining with this t2, and that is going to give us about 1.2968. So we have got T1 and T2. So if we want a total time of flight from the beginning of motion to the very bottom, we're supposed to add these two times. So T capital T is going to be 1.1725 plus 1.2968. And that will give us an approximate value of 2.469 seconds. So we see that whether you use this formula or this formula, you're going to get the same value. So we're also able to use that one. Now the next one, we want to find what is the horizontal distance traveled by the arrow after reaching the ground. The horizontal distance traveled by the arrow after reaching the ground. So the distance we're talking about is here, the range from the beginning of motion to the end. So range is given by velocity in the x multiplied by time of flight. Velocity in the x is given by v cos theta multiplied by the time. So velocity is 15, cos the angle is 50. The time of flight we are just from calculating 2.469. So this is going to give us about 23.8 meters. So that is going to be it for this question.